You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, everybody out in the world, and welcome to the Common Descent Podcast, where we talk about paleontology, evolution, Earth history, and so on. This is episode 171, and today's topic is the Tethys Sea.
What's the Tethys Sea?
Well, if you're a fan of paleontology, there's a good chance you have heard of the Tethys Sea. I remember hearing about it when I was a kid, especially in regard to dinosaurs and stuff. We've mentioned it on the podcast a handful of times. It came up during Snake Month when we were talking about ancient sea snakes. The Tethys Sea is an ancient ocean that no longer exists as the Tethys Sea today. This is not the first time we've done an episode about an ancient body of water. We did the Western Interior Seaway.
Yep.
Exactly 100 episodes ago. We will talk in this episode about what it is, where it came from, what lived in it, all that sort of typical stuff. But this discussion is going to be a whole lot more about what is the Tethys Sea, because there have been many versions of the Tethys Sea. This isn't a single body of water. We will be talking about many different bodies of water in this episode.
Yeah. Man, I can't wait for 271 to see what water we talk about then.
Oh boy. Some sort of future body of water that doesn't exist yet. This episode topic, like all of our episode topics, was requested. This one by Jackie and Aaron. Thank you for the request.
Thank you very much.
Before we get into the meat of the episode, a few announcements. First and foremost, we have a Patreon. Everything we do on the podcast is supported by the generous donations of our patrons. Patrons get all sorts of fun goodies, bonus content, live streams with us, special prizes, but also at a certain level, we shout your name out on the podcast. This episode, we would like to welcome new patrons Aspen, Leah, Luke, Tim Paxu, R. Williamson, and Danielle.
Welcome. Thank you so much.
A thank you to our new patrons and to all of our patrons that have always supported us. We really appreciate it. If you, dear listener, would like to support our science education efforts, consider joining our Patreon. And speaking of exciting Patreon-related stuff, it is August now.
Yep.
Which means that Croc and Snake Month are officially over. A huge thanks to everybody who participated in our Croc and Snake Month stuff. We had themed live streams, we did Discord Q&As, we had the Croc and Snake channels on Discord that were full of all sorts of cool conversation, and an extra special thanks to all of the people who joined the Croc and Snakes tier on Patreon, which provided pledges to contribute to donations that we can now make towards croc and snake conservation and education efforts. Thanks to that support, we will be making donations of $300 each to the Rafael Crespo Conservation Fund for crocs and the Harold K. Voris Aquatic Snake Research and Conservation Grant for snakes. And on top of that, we are also going to be making $100 donations each to the Crocodile Research Coalition and Save the Snakes, the two organizations that we not only donated to last year, but whose members joined us on the podcast for Croc and Snake Month. Thank you so much to everybody who supported us, who joined the Patreon, who joined in Croc and Snake Month and helped us to do this. We love having the opportunity to not only geek out about the best groups of reptiles, your decision may vary, but also to directly contribute to research, conservation, and education efforts around these animals.
Yeah, no, these last 2 months were tons of fun, so thank you all so much for making it so. And thank you so much for allowing us and making it so that we could make these donations and participate in conserving these awesome reptiles.
Absolutely. Please spend the next 10 months in eager anticipation of next year's Croc and Snake Month. A couple more things. Speaking of ways to get involved, we are always accepting requests for episode topics here on the podcast. And now if you go to our website, commondescentpodcast.com, there is a topic request button right there on the website. A super easy new way for you to submit requests. We've already gotten a few requests. So if you have an idea in mind, that is now an option. Go to the website and click the conveniently located request topic button.
Yeah, you can find the link at the top, side, and bottom of most pages on the site, and it'll take you right to the form, and then you can request directly.
Yeah, we've actually been working on a number of updates for our website, so this is one of those. Stay tuned for more. And speaking of things that are coming up, DragonCon's coming up!
Yeah!
And we will be there again. As with previous years, we will be participating in panels talking about science at DragonCon. We don't know what those panels are yet. We will announce them. Hopefully in the next episode we'll have the details. If you're going to be at DragonCon in Atlanta, feel free to find us, walk up to us, say hello. We'll be talking about science. We'll also be wearing costumes.
Yeah!
So we're going to have a good time.
I'm very excited.
And with the announcements out of the way, let's move on to the news. Every episode, we like to pick some new news from the world of paleontology, scientific studies, things that interest us, that we think will interest you to keep us all up to date on what's happening on the cutting edge of science. Will, what's the news?
My first bit of news is technically a bit of news that would make much more sense for June,
Sure.
because it is croc conservation news.
All right. You know what? Croc and in our hearts, Croc and Snake Month are all summer at least.
Yes, absolutely. This is research looking into the stability of at least one croc breeding program for Orinoco crocodiles in South America. This is research by Ana Saldarriaga Gomez et al. In Nature Conservation, and the article is a press release by Pinsoft Publishers in phys.org. So, Orinoco crocodile, Crocodilus intermedius, is one of the most endangered crocodiles. It is critically endangered, native to the Orinoco River, as it gets its name, in Colombia and Venezuela. It is also one of the largest species around today. Like, these can get up to the 15, 16 range on average. They are by far the most endangered species in the New World, so here in the Americas, and has been persecuted for its skin mainly. Skin trade, it is very, very popular for poaching, and estimations for its population range as low as 250. Some have gone up to 1,500, but a lot say under 500 very likely.
Which is not very many individuals for a population.
That is very, very small. The largest singular population is in Venezuela, and is definitely at least fewer than 500 there. But, as we have mentioned before, all crocs are now protected, and this includes the Orinoco, and efforts have been put into place to try to aid this population. The one that they were looking at was a conservation effort put in place in 1971 by Federico Medem, who was a herpetologist that established the Roberto Franco Tropical Biological Station in Villavicencio. This facility, this place, currently houses over 600 crocs, making it the largest stock of the species and the only one in Colombia, and could potentially be more than there are wild.
Right.
So, this is a big deal, but reintroduction has been tough because they haven't been able to confirm the genetic stability of this population. Are they genetically viable enough to be released without lowering or threatening the genetic stability of the overall population? Basically, the main things they're worried about are inbreeding. When you breed two closely related individuals, you can lower the genetic diversity, and you can lower the genetic health and viability of not only that individual, but the population.
Right.
It's also known that very commonly in captive bred populations, genetic diversity is just, generally speaking, often lost over time.
Mm-hmm.
So it's a concern. But they didn't have all that data on hand to be able to make that call, so it's been kind of a sticking point that's been slowing things down. This research aimed to solve that. So they used genetic analysis of 17 microsatellite loci on the genetics of the crocs to try to get a sense of their genetic situation.
Right. Looking at particular key parts of the genome that represent the genome as a whole.
What the article described as fast evolving molecular markers. So
cool.
Parts that would show the change more quickly. And the total sample was 551 crocs, the adults in the population, and including the founders, the original specimens that would have started this breeding population. They use this to try to estimate the level of inbreeding, the number of alleles they're dealing with, to figure out the richness and how common they're seeing these different features and the amounts they're seeing of these things. Heterozygosities was another one they listed, which I know that term, but I always forget what that actually is dealing with.
I think heterozygous refers to when you've got the two copies of the allele at a gene are different.
That sounds right.
As opposed to the same allele of a gene having two of the same one. I think that's what that refers to, but I don't.
That's what I remember.
Go back to episode 147 about genetics.
Yep.
And learn about all that.
This is intro genetics stuff, and I haven't had that in so long.
It's just
all the
terminology.
vocab.
We could look it up, but
Yep. I forgot until I got here and went, oh, right, that word.
An exercise for the reader.
So basically, they're trying to figure out what is the situation of the population genetics for this group.
Right.
How inbred are they? How diverse are the different setups of the alleles of the different genetic situations for each individual, to try to figure out, is this population viable?
Is it genetically healthy enough to start mixing with natural populations?
They were also taking into consideration the relationships between the crocodiles, who's related to who, combined with the size, the sex, and location that individuals would have come from. And what they found was, it seems like they've maintained the diversity from the founders.
Oh, very cool.
So they have not become significantly inbred over the time. There was breeding was being taken in consideration by relatedness, but they weren't actually doing genetic studies, especially when it first started.
Right. They were. It's probably not very flattering to say they were eyeballing it.
Yeah.
But they were kind of eyeballing it.
Yes.
You did not have that genetic data.
They were able to keep track of this croc came from a clutch of eggs from those two crocs, so we know not to breed them back.
Right. This should be having the desired effect, but without that genetic data, it's hard to confirm that that's true.
We didn't know that we were avoiding the genes becoming homogeneous. This seems to show that there is a significant amount of diversity. They said a sufficient level of genetic diversity.
That's what you want.
High levels of heterozygosity, low overall inbreeding, which means, according to this research, their stamp of approval, it's suitable for release.
Very cool.
Which means that this is scientific evidence, published evidence now that the governments could use to start potentially reintroducing some of these individuals to areas where the populations have been hit hardest. So this could actually spark a next step that has not really been able to been moved forward on because of this lack of knowledge.
Yeah.
They also noted that this is a great example for why keeping track of the genetics for a breeding population can improve the management strategies and management approach better than what they called a pedigree information-based alone.
Yeah, this kind of study is very cool. Not only is it great because it's potentially furthering conservation of this endangered group of crocs, but also it really demonstrates the complexity of conservation efforts.
Yes.
Which is a great thing to have some perspective on, especially where there are so many relatively dire cases. And sometimes conservation efforts can happen unexpectedly slowly or frustratingly slowly, in particular from an outside perspective. And so it's very good to be able to talk about these examples where, here are things that if we're not careful with this, if we're not taking the time to do this, we can accidentally make stuff worse.
Yes.
So getting some insight into that really helps to sort of to understand the conservation process.
Yes. And just to make it clear, this type of genetic study and monitoring for a breeding population isn't like the first time.
No.
This is a common practice with zoo breeding populations nowadays. But this project was started 50 years ago.
Right.
And it wasn't common practice at that point. So this is kind of retroactively trying to catch this important breeding site back up to our modern practices.
And also, way to go.
Yeah. Oh, yeah.
Good job, everybody working at that place.
You nailed it.
You did it. You did it right.
That's so cool. And it makes sense because, they were still following the logic. They just didn't have the confirmation of actually having looked at the genetics. So awesome.
Very cool. Hey, my first bit of news is going to take us back into fossil stuff, but I'll stick with archosaurs. There's some dinosaurs here. This is research describing the incredible fossil find of two ancient animals together as I think the paper actually put it this way, locked in mortal combat. And we'll talk about exactly what that means here in just a second. This is research published in Scientific Reports by Gong Han et al., and we will link in the blog post to an article in Smithsonian Magazine by Margaret Osborne. We've mentioned before on the podcasts instances where you get fossils of multiple organisms together, things that were eating other things, things that live next to each other. There are a couple of famous examples of fossil things seemingly preserved in the moment of fighting each other.
Yes.
The most famous example probably is the Protoceratops and Velociraptor that seem to have been buried in a sand dune while tumbling around each other. The famous fighting dinosaurs.
Yeah, where it actually seems like we can see bites and clawing happening.
Right. This is another one like that. Two skeletons, two animals, seemingly entangled, buried very quickly. In this case, it is a dinosaur and a mammal.
Ooh.
Locked in seeming combat. The mammal is a relatively well-known Mesozoic mammal, Reptiles. This is a cat-sized, like a house cat-sized animal, about 0.5 meter long, 1.5 feet, about 7 to 8 pounds, so 3 or 4 kilograms, which pretty big for a Mesozoic mammal.
Mm-hmm.
The dinosaur is Psittacosaurus. Psittacosaurus is a member of the Ceratopsian, the horned dinosaur lineage. We've talked about Psittacosaurus a whole bunch. This individual is bobcat-sized, about 4 feet long, a little over 1 meter, about 10 kilograms, a little over 20 pounds. The two skeletons are more or less complete, intertwined with each other, buried in an ash deposit.
Oh.
The fossils come from the Yixian Formation of China, part of the Jehol Biota, which we discussed at length in episode 152. And if you remember that, it is not a surprise that this kind of fossil came from the Jehol Biota.
Yeah.
That's the kind of thing you get here. These are early Cretaceous, about 125 million years old. One of the coolest things about finding Reptiles and Psittacosaurus specifically is that there is another specimen of Reptiles from this region with Psittacosaurus bits in its guts.
Oh.
So we do know that at least one time this species ate this species of dinosaur.
Yes.
So now we have the two of them entangled together in some sort of confrontation.
This feels very much like we have remains of this dinosaur in one of your compatriots' stomachs.
I swear, no, I just tripped.
Yeah.
I swear I just tripped. It was an accident.
I was trying to help him up.
Now, when I say entangled, here's some details. So they're like curled around each other. If you go to the link in the blog post, you can see images of the fossil. The mammal is partially on top of the dinosaur. The mammal's left hand is gripping the lower jaw, like digits around the mandible. And one of the hind feet is gripping the shin of the dinosaur. The mammal's jaws are around a couple of ribs.
Wow.
Like actually around a couple of ribs. Now, the two skeletons are in a block of sediment, so they're only partially revealed. The preparators haven't taken every single bone out. They left them in that block of sediment, which means there are some things that are obscured. For example, those ribs that are between the jaws of the mammal are broken. But because they're obscured, the authors said we can't tell why they're broken.
Yes.
Were they already broken? Did they break after this during fossilization? Similarly, the mammal's teeth are hard to see, so it's hard to determine. I think they weren't able to determine for sure the species, or at least less confidently. The age of the mammal is a little harder to say because the teeth are obscured. So there are a few things here that maybe future studies will get a closer look at. But, of course, the big question that comes up with something like this is what's the deal? Why are these two animals entangled together? In the paper, the authors do discuss a couple of different options, including that it could be a forgery. Wait, there are known forgeries not dissimilar to this from this region. Based on their analysis of the fossil, they rule that out. This does not appear to be a case of fossils artificially put together. They also don't think that this was like the animals got tumbled up in the sediment or something.
Yeah, exactly.
Based on their analysis of the fossils, they concluded that it doesn't look like there was a lot of movement of the specimens after burial.
It's not super disturbed.
Right. It looks like they were buried in place and stayed that way. If those things are in fact true, then that means we are seeing an actual encounter between these two organisms. It could be scavenging.
Yes.
Could be that the Psittacosaurus was already a carcass and the mammal came along to nom on it. Some things potentially in favor of that suggestion. One, the dinosaur is quite a bit larger than the mammal itself.
Okay.
Cat size to bobcat size, which doesn't mean they couldn't be hunting something a little bit bigger, but could be evidence in favor of scavenging rather than hunting. Also, the jaws being around the ribs could potentially be an weird position to get them in if the dinosaur was fully intact.
Yes, exactly.
Like, that might be that it was already falling apart, so you had access to the ribs. Also, in the article that we'll link to, an outside researcher was quoted in commenting that another potential clue towards scavenging is that one of the mammal's hands is in the jaw of the Psittacosaurus, which is a bad place to put your hand,
yes.
Even a little ceratopsian.
Yep.
That beak is potentially very dangerous if it's alive. On the other hand, the authors point out, if it was a case of scavenging, we'd expect to see more bite marks and things on the bones, which we don't see. Also, they're a bit more intertwined than we might expect for scavenging. Like, you don't have to hold down or hold on to a bunch of parts of the fossil. Like, the legs are intertwined with each other.
You don't usually have to restrain a corpse.
Yes, exactly. And they do have a little discussion about how there are mammals that are known to hunt food that is bigger than they are.
Mm-hmm.
And as far as the ribs conundrum goes, they also pointed out in the paper it is not unheard of for predators to start eating their prey before it's dead.
Yes. Yep.
Like, it could be digging into the ribcage before the deed is finally done.
Yep.
With all of that together, these authors favor the hypothesis that this was a predation event in progress.
Yeah.
That this mammal was attacking the Psittacosaurus with intent to devour, and then this a volcanic ash flow, a lahar deposit, swept over them, interrupted them, and froze them in place. The article does cite a couple of authors who point out potential inconsistencies. It is, as always, as we've discussed before, very difficult to distinguish predation from scavenging. Even in a case like this, where it seems like it would be way easier to be able to tell. But especially for extraordinary claims, we like to account for all potential explanations. So this could still be scavenging or something else. But it could also be a frozen-in-time fight between these two little animals.
Well, and I really appreciate them listing out the various bits of evidence for either scenario and emphasizing, that it's difficult to tell apart. Because as you said, it's hard to tell, but it's hard to tell even like modern day. Like, if you find a lion eating a wildebeest, you don't know that lion is the one who killed that wildebeest.
Yes.
It could have been killed by another lion. Mm-hmm. It could have been killed by hyenas. But you can't.
Yeah, it could have just died.
It could have died.
It's just fallen over.
How different does an animal eating a corpse that was already a corpse when they got there versus when they made? Effectively, you're doing the steps are the same once the animal's dead. So it is really hard and sometimes nigh impossible to actually confirm what was the actual events that took place directly before this.
Mm-hmm.
We know you're eating this thing. That is clear. Ooh, how did you get to that situation? It's very hard because that act looks the same.
Yes.
Kind of regardless of what happened before it. So I really appreciate them laying out the evidence because that's important to be clear on. We need to look at this from all angles because we can't just easily draw a conclusion.
So go click the link. The paper, I believe, is open access, so you can read through their description, see the images. I encourage you all to take a look and see that interaction, whether it was caught in the act of hunting or not. This is a direct interaction between two different species of the time. two different species that we already knew had a predator-prey relationship, which is very cool. And just on top of all that, two complete skeletons.
Yeah.
They're not rare animals from the time, but they're complete skeletons, and that's a super cool thing to find.
No, this specimen is awesome no matter which way you cut it.
Yes. Don't cut it.
No, yeah,
Leave it that way.
Yes, no, please. In the rock, nice and preserved. Well, my next news is about evolution. It is back to modern, though.
Okay.
At least,
we're doing a little mixture.
Looking at the modern situations.
That's fine. A lot of the discussion of the episode today, a surprising amount of today's episode discussion, will also be about modern stuff.
Nice.
Yeah.
This is a study that looked at, can aquatic mammals ever come back to land?
Oh.
Yeah. As a question that's been asked for, this one tried to actually quantify.
Have they evolved themselves into an evolutionary corner?
Yes, exactly. This research is by Bruna Farina et al. In the Royal Society B Biological Sciences, and the article is by Jacqueline Kwan in Live Science. So, transition from land to water, we've talked about secondarily aquatic animals is a fairly common phenomena.
Yes, we talked about it a bunch this summer.
Yes, we did. But a evolutionary question that has been asked and looked at, and kind of, just a philosophical question that's often been looked at, is that the transition from water to land invertebrates, as far as we can tell, only happened once. So it's gone it's gone back many, many times, but it's only ever really come the other way one time, which has raised the question, does that mean once you go back to the water, it's not really viable that you can ever come back again to land? And so this was trying to look at that specifically in aquatic mammals. Could aquatic mammals ever readapt to terrestrial life? One of the things they wanted to do here was to expand the level of aquatic adaptations looked at, because very often when this is discussed, the main two conditions that are looked at are terrestrial and aquatic. But the semi-aquatic and partially aquatic steps in between aren't often as studied. And so there's a lack of understanding of the full breadth of terrestrial to aquatic gradient. And they wanted to take it all into this perspective. They used a phylogenetic comparative method where they were looking at mammals today, basically all mammals today, and putting them into the phylogenetic tree to look at how they're related, their evolutionary history, so to take into consideration how they have, gained the adaptations they have for terrestrial or aquatic lifestyles, and then using this model to try to predict which groups are likely to be able to, or would likely be able to evolve certain traits. Overall, they studied 5,600 mammal species.
That's pretty much all of them.
Yep. They divided them into 4 categories. Fully terrestrial, so just living on land. Those with some aquatic adaptations, but still very mobile on land. Species with limited locomotion on land, so your real semi-aquatic groups that can move on land, but not very well. And then fully aquatic groups, whales being the main example there. Looking at all this, the model helped them estimate the probability of these groups being able to evolve certain traits. And what they found was that there seems to be a threshold between semi-aquatic and fully aquatic that once passed cannot be reversed. Based off of their estimates, based off these predictions, semi-aquatic groups seems for many of them like they very well could reverse. That an otter could come back to being fully terrestrial. That is likely.
Right.
Or
you still have a suite of traits that could be, in evolutionary terms, relatively easily adjusted that could allow you to respond to selective pressures pushing back into a land lifestyle.
Yes. What they said is those groups seem like they could be reversible. You could reverse back to being just terrestrial. But for aquatic groups, fully aquatic groups, it seems that most of these are irreversible. Much like we talked about with the diving birds in that one news, that once you've gone full whale, that doesn't really seem that there's any way, based on this, that you could come back to being on land.
Right.
And so that there are small steps that you can take to go from terrestrial to semi-aquatic that can be reversed. But once you pass that threshold, past semi-aquatic to fully aquatic, that becomes a gate. They noted that this is consistent with a evolutionary concept known as Dollo's Law, which states that once a complex trait is lost in a lineage over time, it is very unlikely to ever reappear in following generations.
Well, this came up not too long ago on one of our snake discussions where someone asked, do we know of cases where snakes have re-evolved limbs?
Yes, exactly.
And
or
it's
what
one
would
of
it
those,
take?
right, what would it take? And often the answer is, it's not totally out of the question that somewhere down the evolutionary line, something limb-like could potentially evolve in a group like that. But re-evolving the same limbs that were lost seems like a major evolutionary hurdle that just has not been done.
Yes. This is a concept brought up in the 19th century by Louis Dolo, a Belgian paleontologist. And Dolo's law seems to show up a lot of times in these macroevolutionary studies that very often when we find you've evolved into a very specialized lifestyle, it seems very unlikely that you'll ever come back from that.
Right. As opposed to examples that we've talked about before where you do have groups that might keep switching back and forth from a little bit more aquatic to a little bit more terrestrial. We've seen that with crocs, for example.
Yes, exactly.
Where you have lineages that kind of keep hovering across that threshold, but going fully marine seems to cut off the ability to go back and forth.
Yes, and even with the crocs, there was only ever one example of them coming back from saltwater to fresh. And so something about it seems to be a mostly one-way street. They also noted some other trends that they found in the transition to aquatic that they were keeping an eye out for. The two big ones is that does seem to trend with an increase in body mass.
Sure.
Likely for thermoregulation. Bergman's rule that larger members of a group tend to be in the colder environments, and the ocean is really good at sucking heat out of bodies. And a trend toward carnivorous diets.
Oh yeah, that makes sense.
Which they noted is likely being associated with a higher nutritional diet for their now increased metabolism.
Yeah, it's also a lot easier to find fish than plants in the ocean.
They noted that this also could be some of the aspects that make it hard to ever come back and compete with terrestrial life forms. That you may have specialized in a way that is not useful on land and would actually put you at a disadvantage.
Yeah.
Some researchers, though, have pointed out that this paper only focuses on mammals. So there is great hope that this could be applied to other groups that have returned the water, reptiles and so forth, to see if this actually holds true, or is this a mammal thing?
Right. It's really interesting because it also sort of intuitively tracks with our knowledge of the one time that we know for sure that vertebrate life did go from fully marine to terrestrial. We know that fish did that. Episode 77. And while there are a bunch of different groups of fish that have some terrestrial ability, like mud skippers, things like that, as far as we know, fish only made that transition one time, which does seem to track with that logic that it's just really difficult evolutionarily to take a fully marine body plan and adapt towards terrestrial life.
Yeah, which, on the surface, it seems like if you can go one way and then you can also go the other way, shouldn't they be even? But it sure does seem like that's not the case.
Very interesting. Well, we've got one more bit of news. This is another bit of news with archosaurs and possible evidence of predation.
Oh.
This time, trace fossils
Okay.
of birds.
So at this point, we're just at the chalk outline and the...
Yes! We'll draw chalk around where the body is. That way, we'll know where it was. This is research by Carlos Neto de Carvalho et al. In Quaternary Science Reviews, and we will link to a press release in phys.org by Hannah Bird. Like I said, this study is about trace fossils, trackways, of birds, which the authors note right away, bird tracks in the fossil record are very rare.
Oh, interesting.
We don't get a whole lot of footprints of trackways of birds. This study documents a series of bird tracks from the late Pleistocene of Portugal, and they note in the paper, these are the first bird ichnofossils reported from the Pleistocene of Europe.
Wow.
Not a very common style of fossil to find.
I mean, I guess it makes some sense. Like, you're small animals, so you're not leaving big fossil,
Sure.
trace fossils, and you're light, and typically you can be in the air and up off the ground,
Yes.
perching, and so, like...
You don't do a lot of walking.
You don't have to be walking on the ground like everyone else. So I guess it makes... I just had never considered.
Yeah. These fossils are from the Malau Formation. This is a coastal sand deposit. These are dunes on Pessegueira Island in the southwest of Portugal. They are between 130,000 and 12,000 years ago, so late Pleistocene. This area, the surfaces of the rocks here that have trackways on them, there are other tracks that have been found here, including rabbit, deer, fox, lynx, and elephant.
Oh, cool.
This is the late Pleistocene.
Yeah.
Very cool stuff. This study describes a variety of bird tracks. These include gulls, which, if I remember correctly, they said was the common one, and are comparable with gull trace fossils from other parts of the world. Curlews, and possibly coots.
Oh.
So a handful of different types of bird trace fossils. And the paper describes 2 new ichnotaxa. So, as we've discussed before, every time you describe a new thing in the fossil record, it gets a new taxon, is a new species, sometimes a new genus. Trace fossils get their own names, which are ichnospecies, ichnogenus, ichnotaxa as a whole. They named 2 new ones. The first is Corvidichnus odomarensis, which is a walking track that they've identified as likely belonging to western jackdaw, a species known from the region. And the other is Buboichnus vicentinus, a walking track of Eurasian eagle owl.
Oh, okay.
They took a bunch of photos of the tracks and then used them to create 3D digital models. This is a process called photogrammetry that some of our audience may be familiar with. They were able to identify these birds based on the distinctive toe tracks. In the press release, they mentioned that eagle owls, for example, have a distinctive K or X shape to the tracks because of their weird-shaped feet.
Yes.
This is interesting, and this is just a little bit of commentary from me. This is a kind of an unusual circumstance because they are describing these ichnospecies and classifying them as specific bird species.
Yes.
Which we normally don't see paleontologists do, because it is very difficult to say if a footprint came from a specific known species, which is part of why fossils get their own species
because
names.
we can't always, and very often, definitely can't, reliably connect the footprints to the producer, even if we are pretty sure of, like, the only one it would make sense for is this other fossil species we found in the area.
And I assume that that's the case here. This paper is not open access, so I wasn't able to go in and find their specific logic for it. I infer that these species have been found in the fossil record of this region and are the species that best match.
Yeah, there's no other candidates that
fit. This kind of bird left these tracks, and the example of that kind of bird in this area is this species. But it is a little bit weird. It was a little bit. I was a little bit surprised that they were linking them to known particular species. Mm-hmm. The other thing that's notable about this, and the part that's making the headlines, is that the track assigned to eagle owl, a number of footprints, intersects with the trackways of 2 smaller birds. Mm-hmm. So you have a few trackways, 2 footprint tracks of smaller birds, and then this trackway, this walking track of the eagle owl. And in the place where they all intersect is a highly disturbed area of sediment that the authors describe as difficult to interpret. The sediment's just all messed up.
Yes.
In that area. Now, that could be a coincidence.
Yes.
It could very well be that. It is often very difficult to tell with trackways, as we've talked about before, whether or not footprints that you found next to each other were actually left there at the same time.
Yes.
They could have been days apart. They could have been hours apart. That's very hard to know. But if these are trackways that were left simultaneously and interacting with each other, they note that a potential explanation for that disturbed area could be that these birds met with each other and had a little scuffle. Mm-hmm, mm-hmm. And if so, it would be the first trace fossil evidence of a bird predation event.
Yeah.
If that's what we're seeing here, that is unprecedented in the fossil record. Which makes absolute sense that you wouldn't get a lot of footprint tracks showing bird hunting behavior, because that's not usually where it's happening. So this, like that other bit of news, this is one of those cases where it is very difficult to say for sure, is this actually some sort of predation event? But intriguing enough to at least make it discussion worthy.
Yes. These sorts of findings always make me think of like the joke sitcom scenarios of we the audience have gotten to see all the various things that led up to, but then a character walks in on a scene, and once you just only see it in that moment,
Yes.
it looks like a completely different scenario.
It's not what it looks like.
Exactly. That's
Yes.
very often with trace fossils, you deal with that kind of stuff of these two smaller birds, did they meet up, have a kerfuffle, and then the owl walked by later and was like investigating what had happened? Like, that would leave the exact same pattern of footprints.
Or did they all three walk across that area at different times,
Yep.
and then something else happened
Yeah.
in that spot?
You know,
Just like a stick fell on it and messed up the sediment or something.
the owl decided to take a dust, a dust bath,
Right.
and fluff its feathers in the sand sort of thing. So, like, there's a bunch of scenarios that could cause this.
Mm-hmm.
And it is often really difficult to actually empirically say which of those follows Occam's razor and is the most likely.
Right.
That's hard to math out as to which one makes the most sense and is the most reasonable. That often opinions come into that, so it's hard to get a single solid answer on which one we should lean toward.
Yeah.
So it can be tricky interpreting these situations.
So it's a very cool find.
Mhm.
Bird traces, identifiable bird traces, very rare style of ichnofossils from this part of the world. For what it's worth, I'm highly skeptical
Yeah.
that this would be it could be.
Yes.
And that'd be awesome. Again, I didn't get to read like the details of their analysis and justification for it.
Mhm.
At some point, I might be able to get a hold of the paper itself and go into more detail.
Well, and I'd be curious of things like how often do owls stalk on foot? Like,
Right. Did you happen to encounter something and then decide to grab it and
Yeah.
fly away?
does that happen with owls very often? Is that
Mhm.
a thing they behaviorally are known to do? Or are they? Would that be weird for an owl to do?
Right.
I don't know. I don't know owls well enough.
Yep.
Sort of thing.
Same.
Would you be able to sneak up on two small birds out on the dunes?
Right. Is
Would
this
they
one
not
of
have
those-
seen you coming? Sort of thing.
One of those things where the prey just got weirdly close to a predator that wasn't acting very... They were like, it's on the ground, it can't do anything.
Yeah, it's just for whatever reason they were not on edge, and you were able to walk up.
And you just got the
Yeah.
chance to grab one. So there is a scenario that you could concoct
Yes,
that could make it make sense.
Nothing about this says it wasn't a predation event.
Right.
Like, there's nothing that goes, well, that doesn't make any sense for a predation. No, it
could.
absolutely, but it also could fit a dozen other scenarios, so it's very hard to
Yes.
figure out which one you should put your flag on.
This is another one. Check out the press release that we linked to. You'll get to see the image of the trackways, and it's pretty cool to see them all in relation to each other.
Cool.
Well, that's all the news for this episode, which means it is time for us to move on to our main event. This episode, we are discussing the Tethys Sea, a famous ancient ocean, and in fact, several famous ancient oceans. What do I mean? Well, let's get into it. After the break, we'll talk about that.
Tell us all about it.
No, remove that. Cut that part out. I think the earliest memory that I have of hearing about the Tethys Sea was in the Magic School Bus in the Age of Dinosaurs computer game.
Yeah.
From way back in the day. It was one of the places you could visit in probably the Cretaceous or the Jurassic period. The Tethys Sea is most often, in my experience, discussed in regards to the Mesozoic era.
Yes.
The Tethys Sea is an ancient body of water, an ancient ocean, that existed at a time where the continents were all in different places, which is how you get different oceans.
Yes, exactly.
We've talked about continental movement on the podcast a whole lot, and different supercontinents and ancient continents and islands and all that. We have talked far less about the fact that when continents reorganize themselves, inevitably oceans are also reorganizing
Yeah,
themselves.
because that's how we name the bodies of water on our planet, is in relation to what landmass cuts them off or
Yes.
encloses them.
The
or
oceans are the negative space between the continents.
Because, like, really, it's just all the blue. And it's
Right.
It's been the same blue. We've just been moving the solid pieces around.
Tethys was originally named in the late 1800s, 1893, by Austrian geologist Edward Suess. The name Tethys is the name of a Greek sea goddess,
Oh, it is.
the wife of Oceanus,
Yeah.
because old school paleontologists were really into Greek naming
Yep,
conventions. The classic Tethys Sea, so in my head, especially before I took all the notes for this episode, the image of the Tethys Sea is effectively an embayment within Pangaea.
That's exactly how I picture it. Yep.
So the supercontinent of Pangaea that existed late Paleozoic into the Mesozoic era. Pangaea, as we've discussed before, was kind of the shape of a letter C.
Yes. And C is for Tethys Sea.
And the inside of that sea was the sea. So the continent curved around this body of water, kind of the same way that the Americas curve around the Gulf of Mexico.
Yeah, exactly.
That area. But over the years, the way that scientists have conceptualized and understood the Tethys Sea has changed, including imagining it as a large shallow sea, a narrow seaway, a series of ocean basins, and eventually as a consecutive series of changing versions of a similar ocean.
Yep.
Nowadays, the name Tethys Sea has been applied to multiple bodies of water throughout hundreds of millions of years. You will sometimes hear distinct names: Paleotethys, Mesotethys, and Cenotethys, roughly corresponding often with the Paleozoic, Mesozoic, and Cenozoic. More recently, and the more common ones that I've seen, include names like Paleotethys and Neotethys.
Yep.
Also Paratethys. I've seen Peritethys. There's a Prototethys. We'll go into what all of this stuff means
Perry the Tethys Sea.
as we go through the history of this body of water. We understand the Tethys Sea and its various iterations and where it was based on the sediments left behind. There are, in the modern day, geologic formations built of sediments from the Tethys Sea, or often its shorelines, are found in many places, especially in the Old World, including lots of places across Europe, the Middle East, Asia, North Africa, very famously in places like the Sahara, the Alps, and the Himalayas. Lots of Tethys Sea sediments. As we discussed when we talked about supercontinents in episode 141, and when we talked about plate tectonics in episode 122, we use a variety of different forms of geological evidence to interpret how continents have moved and changed over time. When we're reconstructing the ancient forms of the Tethys Sea, we're doing the same sorts of things. We can find sediments deposited on shorelines to tell us where there were shorelines, mountain building events, orogenic belts, so places where the rock has been contorted and distorted by mountain building, are the sites of former continental collisions. We can find geologic evidence of rifting zones where new basins opened up, or subduction zones where basins' ocean floor was subducted under adjacent continent. Also, we can look at the distribution of fossils to see when passageways opened or closed on land and in water. All of these evidences together is how we interpret and reconstruct the shape of our oceans and continents. As is so often the case, the farther back in time we go, the harder this becomes, which is why we tend to have a better idea of things the more recent in geologic time they are. While I was looking at various papers about the Tethys Seas, I expectedly found that there has been quite a bit of debate over certain aspects of reconstructing it, especially as you go farther back in geologic time. Now, with all of that preamble having been laid down, let's go through a brief history of Tethys oceans throughout time. The earliest, quote-unquote, Tethys, as it were, is a sea that is sometimes called the Proto-Tethys Ocean. This is a body of water that existed during the late Proterozoic into the early Paleozoic. So this is a body of water that is pre-Cambrian.
Yeah, wow.
This is the later parts of the Proterozoic. I have seen the Proto-Tethys described as poorly defined or little known. During this time period, there was the supercontinent of Rodinia, which is the supercontinent before Pangaea, as we've discussed before. At this time, Rodinia was coming apart. And when bits of continent come apart from each other, they form ocean basins.
Yep.
A rifting zone eventually becomes low enough elevation to water fills it up, and you now have a new basin. At that time, Gondwana, all those southern continents, was a major continental mass in the southern hemisphere around the South Pole, and as the continents were splitting apart, pieces were just coming off of these major bits of continent. The Proto-Tethys was an ocean that sat between the mainland of Gondwana and separated blocks such as Baltica and Siberia.
Mm-hmm. Mm-hmm.
This is sort of how, if you think about like the South China Sea today is between mainland Asia and the Philippines and other separated bits of continent. The Tasman Sea is between mainland Australia and New Zealand. That was sort of what the Proto-Tethys Sea was like.
Yeah.
As the Paleozoic moved along, and now we're in a world with fishes and complex ecosystems in the ocean, more rifting continued to happen on the edge of Gondwana, south of the Proto-Tethys Sea itself. This broke off more continental pieces, which started to spread north across the ocean, and in that space where they were splitting off, a new ocean basin opened, which would go on to become the Paleotethys. The Paleotethys grew as the Proto-Tethys disappeared.
Yes.
The oceans will also shrink over time as either continents are moving around or other ocean basins are spreading and taking over their space.
Yeah, so even these early versions were still oceans within or between land masses, like among the land masses.
Mm-hmm.
You know, it's not like the Pacific today where the Pacific is most of the expanse of water.
That whole part of the world.
Yes, exactly. While we have oceans like you were describing that are distinguished by the land they're kind of, pocketed by.
Right. Well, the Atlantic Ocean is between the Americas to the west and then Europe and Africa to the east. And
Yes.
the Indian Ocean is sort of surrounded by a bunch of bits. But the oceans are all connected to each other.
Yeah.
This would have been very similar. As the Paleozoic goes on and this continental movement continues, we eventually see the formation of Pangaea. As you probably know, especially if you've listened to us before, Pangaea was another supercontinent. During the time of Pangaea, most of the landmass of continents was one large connected piece, Laurasia in the north, Gondwana in the south, and most of the rest of the world was a single ocean called Panthalassa. But as Pangaea came together, it created that curved letter C shape roughly form, so you had this body of water in the middle. That is the Paleotethys. Pangaea starts coming together around this Paleotethys Sea, which is bordered on the east by a couple other chunks of land, particularly North and South China, which were at the time were separate. Today they are North and South China. By this time, the Paleotethys has also shifted up to be in the tropics.
Yeah.
The equator cuts through this Paleotethys Sea, which makes it a nice warm ocean surrounded by this continental landmass. This is that classic Tethys position.
Yes.
Right? In the sort of the heart, well, not really the heart, off to the east, the eastern heart of the supercontinent of Pangaea.
Well, it's very much, Pangaea was like a cup. And
Yes.
the Tethys is what was filling that cup.
That is the shape, the orientation of ocean and continents that we are in moving into the Mesozoic era, the age of reptiles. And as we get into the Triassic, more rifting starts to happen, again, off of Gondwana, on the southern edge of this Paleotethys. A strip of continental land rifts away and begins to move north across this Paleotethys. That strip of continents is sometimes called a continent itself, or a microcontinent, or a series of microcontinents. It is called Cimmeria. It would eventually, once those parts finally made it all the way up to the northern continent, would eventually contribute parts of Turkey, Iran, Afghanistan, China, Malaysia, a bunch of other pieces in that Arabian, South Asian area of land that we have today. As this strip of land rifted away from Gondwana and started moving north across the Paleotethys, it opened a new oceanic basin.
Yes.
And as they moved from Gondwana up towards Laurasia, the Paleotethys slowly closed.
Mm-hmm.
And what opened underneath it is sometimes called the Neotethys, although I have also very regularly seen it called the Tethys.
Yes.
The Tethys Sea. This is sort of the famous version of the Tethys Sea that is often referred to. It slowly overtakes and replaces the Paleotethys, which is a really interesting... It's the same area.
Yeah.
But as this mass of continents swiped from south to north across it, it erased the Paleotethys, which was being subducted underneath Laurasia, and opened the new Tethys.
It can be kind of a weird concept to think about because the water hasn't changed.
Right. And even the shape of the ocean, for a while, remains relatively similar.
And so I think it like, when I've learned about this, when I first learned about this stuff, I remember struggling with it because when I think of a sea, I'm thinking of the water.
Mm-hmm.
So, all right, but no, the water didn't disappear. This isn't new water. This isn't new sea.
Right.
But the sea floor is new.
Yes. The oceanic basin is changing.
Because continents aren't floating across. The ground is shifting all the way down to the sea floor. And so, like an Etch-a-Sketch, we are moving across and erasing all of the previous seafloor with new seafloor.
Exactly. Over the course of the Mesozoic era, this new Tethys continues to evolve. It eventually consists of multiple ocean basins joined together, including a shallow seaway that extends to the west into the region that now is Europe. Eventually, later in the Mesozoic, North America begins to split away from the other continents, opening the central Atlantic, and eventually that arm of the Tethys connects all the way through. So you had the Atlantic underneath North America, going up and connecting through what is today the Mediterranean and European region, all the way into the bulk of the Tethys, which means that for a while we had a ocean connection around the whole planet in the tropics.
Yeah.
A circumglobal connected tropical ocean, which we do not have today, which is a very interesting thing to think about.
And yet, man, what must the currents have been like?
Yeah.
Like that's just a situation that has not been the case for quite some time. So like, what were the waters moving like when you could actually circle the globe
in the
boats?
tropics?
Yeah, like if you had a boat back then, you could have just whoop.
Yep. You don't have to, like today, when people in human history wanted to travel around the world, you have to go underneath South America or underneath Africa to make it to the next ocean.
Yep.
This was a time where you could have stayed nice and warm the whole trip.
Yeah. Crazy.
Also, the Tethys was not an empty body of water. There were all sorts of smaller land masses, volcanic islands. Not only did that original patch of continental mass move north, other pieces continued to rift off of the southern continents and move following the spread of that ocean basin across the Tethys. This Tethys Sea, because it was the Mesozoic, was also home to a whole bunch of famous Mesozoic stuff.
Yeah.
The Paleotethys would absolutely have been home to all sorts of Paleozoic life. In the Mesozoic, this Neotethys, very famously, you've got your weird bivalve reefs and your ichthyosaurs and plesiosaurs and stuff like that. We'll talk a bit more about the life of the Tethys a little later on. The Tethys persisted into the Cenozoic era. So on the other side of the end Cretaceous mass extinction, we still have a Tethys that is gradually disappearing against Eurasia. Continental movement gradually closes it off. Africa moves to join Europe and Asia. The final pieces of the Middle East come together. South Asia starts gaining some extra bits, including India, which rockets its way across the sea to meet Asia.
Crash course.
A real crash course. All of these continental accumulations, in addition to those early ones, close off the Tethys Sea proper and not only form the shape of that continental region of the world as we know it today, but also all of that continental collision creates a long stretch of a series of mountainous regions, which includes today's Alps, Zagros Mountains, and Himalayas.
Yep.
Those mountains are the result of the tectonic forces that closed the Tethys Sea.
That's what it took. That's what it took to kill the Tethys.
It took making all these mountains. This Tethys, the Neo-Tethys, is effectively gone during the Eocene into the Oligocene. So about 30 to 40 million years ago, the Tethys, as it has existed for hundreds of millions of years, is no more. If you look at maps, and we'll have some in the blog post after this episode, we'll have maps of the continental distribution over time. The Tethys Sea, visually, sort of gives way and breaks up into what is now the Indian Ocean, the West Pacific, the Central Atlantic, the Mediterranean. These are spaces between the continents that are what's left after the Tethys kind of dissolved away in its former glorious place.
Yeah, well, and it's a interesting concept to me of, we often talk about how humans naming stuff is a funny phenomena, and naming bodies of, a lake makes sense, that's enclosed, but like naming bodies of the global oceans is always kind of funny. Like, yeah, sure.
Very arbitrary.
Yeah, sure. Have fun, humans. Have fun. But like, it makes sense that if you put in enough land masses in among it, it really doesn't make sense anymore to call it one body of water, because you now are going to be splitting up populations of organisms and distinct structures and coastlines and currents. So that's all it takes to really not have an ocean anymore, is fill it with not even contiguous land, but pieces of land.
Well, and considering how we used the name Tethys so consistently for almost the entire Phanerozoic eon, if we were paleontologists another 100 million years in the future, I wonder if the Indian Ocean if we wouldn't have just called that the next version of the Tethys.
Yes.
That is now what we're calling the Tethys.
Well, yeah, and that's also always an interesting fact of, like, the Indian Ocean was named first.
Yes, before the Tethys.
Yeah, because we hadn't done the science to discover that a Tethys had existed. So if we had known about it, would it have just continued?
Mm-hmm. Now, I said that this early Cenozoic is when the Tethys sort of disappeared. That is not entirely true. As the land connections, all these came together to more of a modern continental distribution, a piece of the northern Tethys became separated, leaving behind a stretch of inland sea across Europe into Central Asia, an inland sea that is called the Paratethys. A little leftover.
It's like a little escape pod.
The Paratethys sat north of the Mediterranean and stretched across Central Europe into Central Asia. In the earlier parts of its existence, the Oligocene and Miocene, it had various connections with the Atlantic, the Mediterranean, the Indian Ocean, other parts. But in the late Miocene, about 12 million years ago, which is a very small number to be talking about a Tethys Sea, it officially became isolated and became what I have seen repeatedly referred to as a megalake. Which stretched from the Eastern Alps all the way over to Kazakhstan, covering nearly 3 million square miles, almost 5 million square kilometers, bigger than the Mediterranean is today.
Yeah.
This massive, enclosed body of water left over from the Tethys.
And it would have been a giant saltwater lake.
Yes, eventually it was. Over the following millions of years, it slowly shrank, evaporating lots of water and becoming super salty.
Yes, exactly. Because that's what happens when you enclose part of the ocean, is you have a saltwater lake, which is weird, but that's because it used to be ocean. And if it's not being fed by rivers, eventually you just have all that salt concentrated.
Yes, the Paratethys underwent multiple what are called salinity crises, which the Mediterranean has also gone through these.
Yep.
And we know those happen because we will get these what are called evaporite deposits, which are deposits of minerals that are left behind when water evaporates. Salt and gypsum, I think, is common in these, things like that. The Paratethys was also home to a bunch of endemic life.
Yeah, I bet.
There were organisms only found in the Paratethys. Also, those salinity crises were not great for that life. More on that in a little bit. As the Paratethys gradually sort of shrunk away almost to nothing, what ended up happening is instead of what there formerly was, which is one giant body of water stretching across this region, it left behind a handful of disconnected patches of water. Those are called the Black Sea,
Yep.
the Caspian Sea, the Aral Sea. There's a few others. There's a couple of like big lakes in that region.
Mm-hmm.
Those are remnants of this Paratethys Sea.
I was wondering.
Mm-hmm.
Because I'm like, we're in the right area of the world, and those are all super salty.
Yes. That is left over. The Paratethys was multiple basins.
Yeah.
And these are basins that are still filled with water.
That's awesome.
So there has been a version of the Tethys Sea, keeping in mind, of course, that these are different oceans that have sort of replaced each other and filled in the space with each other. There are things that we call the Tethys going back more than 600 million years, up until just a handful of millions of years ago.
Very cool.
The Tethys also comes up in lots of study about the ancient world, partially just to understand how things have changed over time.
Mm-hmm.
All the stuff we've just talked about, understanding continental movements, applying names to things, understanding what pieces of the world were where. But there is also, of course, plenty of study about how these changing bodies of water affected life on Earth.
Yeah.
So after the break, we'll talk a little bit about the life of the Tethys Sea. When I first started thinking about how to format this episode, I had a little note in my notes that said, talk about what lived in the Tethys. And then as I started putting together all the information about Tethys over time, I very quickly realized that that is a very silly thing to plan to do. Because that's kind of like saying, talk about the life of the southern hemisphere.
Yeah, exactly. Like, what lives in the Pacific?
Right. Also the Tethys not only was big, but these various bodies of water that we've been talking about have occupied almost the entire Phanerozoic eon.
Yes, absolutely.
So, versions of the Proto-Tethys, that first sort of early version, potentially predates complex animal life.
Yeah.
So like everything lived in the Tethys.
Yeah, exactly.
If it lived in an ocean, there is a very good chance at some point it lived in one of these Tethys seas.
Which part of which Tethys at which point do you want to know what lived?
So in the Paleozoic, all the famous Paleozoic stuff for sure lived in that Paleotethys. There are studies of fossil fish from the Tethys, crinoids, other echinoderms, trilobites, the things you expect. Mesozoic life you would have had in the Neotethys, ichthyosaurs, plesiosaurs, mosasaurs, turtles, crocs, and so on. So I'm not going to list everything that is known to have lived in the Tethys, but I will present some highlights, some notable examples of things that are tied to the Tethys that are fun to mention. For example, as I just mentioned, the Neotethys, the version of the Tethys in the Mesozoic, in that, surrounded by Pangaea, the ocean deposits around that Tethys are famous for ichthyosaurs, mosasaurs, plesiosaurs. The famous ichthyosaurs of the Alps are Tethys ichthyo. That's Tethys sediment that was uplifted when those mountains arose. There are crocodilians, or at least crocodiliforms, from the Tethys. Also, go back a couple episodes, those Cretaceous sea snakes we talked about are known from the Mesozoic Tethys Sea.
Cool.
Invertebrates in the Tethys would have included ammonites, those weird bivalve reefs of the Mesozoic inhabited the Tethys. Another famous example of a Tethys thing, the Solnhofen limestone in Germany, the fossil deposit that produced Archaeopteryx, as well as tons of well-preserved pterosaur. I think Pterodactylus, the first pterosaur. I could be mistaken, but that's from certainly that region. The Solnhofen limestone is from around the edges of the Tethys Sea.
Cool.
The Mesozoic Tethys Sea was also full of islands. During the Cretaceous period especially, Europe was an archipelago of islands. It was flooded by this branch of the Tethys Sea that created all of these disparate patches of land, which has been studied a bunch because this means that there are unique fossil assemblages, dinosaurs, early mammals, other things in Europe are often unique to Europe, not found elsewhere. There are also fossils of animals. There are also groups of animals that are really widespread and common during the Cretaceous that aren't found in these parts of Europe, like tyrannosaurs and ankylosaurs. And we even have geologic evidence of specific island ecosystems. One that we have talked about on the podcast before is Hat's Egg Island, which is preserved today in the Romania region, which was home to an island community that included, among other things, dwarf dinosaurs.
Yep.
Such as Megarosaurus, which was a sauropod, the long-necked, long-tailed dinosaurs, the size of a cow, which is preposterously small for a sauropod. That is classic island dwarfing, as we've talked about a bunch of times before. Hat's Egg Island was also home to giant pterosaurs.
Yeah.
Hatzegopteryx is from there, one of the biggest pterosaurs that we know to have ever lived. So because of the Tethys Sea's position in this region, Cretaceous Europe is a great place to study island evolution.
Yeah. Which is such a fun and weird concept of this area used to be an island, but ain't no more, because it got either the water came away from it and revealed connections, or it got smushed up against other pieces of land.
Yes. And in this case, I'm pretty sure for the most part it's a bit of both.
Yep. Which is a cool concept in and of itself, but it's neat to think that the fact that the Tethys used to be here is what caused it to be an island.
Yes. Well, because we've talked about this before. We've talked about islands. Episode 4 was island evolution. We talked about island giants and island dwarfs in episode 144. But when we talk about it, we focus usually on the island.
Yes, exactly.
What makes it an island is that ocean surrounding it, which we often in island discussions ignore that part.
Yep.
That's just the thing you have to get over to get to the island. But the reason that we had islands in this area is because of the changes to these bodies of water.
Yeah.
Speaking of famous stuff from the Tethys, if we move out of the Mesozoic and into the Cenozoic, the age of mammals, the Tethys Sea of the Eocene was also home to the earliest known whales.
Makes sense, yeah.
In episode 41, we talked about the early members of the whale lineage, things like Pachycetus and Ambulocetus, land-dwelling or semi-aquatic mammals that eventually, they were on the lineage that eventually gave rise to true whales. Those are famously known from Pakistan, and then their relatives from other nearby places, from deposits from the coastal waters of the Tethys. The Tethys was also, it seems, the cradle for the early evolution of whales.
Which is kind of a big deal today.
Yeah, it sure is. Basilosaurus is known from that region. Also, not just whales. I came across some papers discussing that the Tethys Sea may also have been the place where sirenians originated.
Oh.
This is manatees and dugongs. Many of the earliest members of the manatee lineage and cousins of the early manatee lineage are known from the Tethys Mediterranean region.
Good place to be a marine mammal.
Apparently.
Huh.
And then as we keep moving forward, that, as I mentioned before, the Paratethys, once it starts becoming more of an isolated inland sea, becomes home to a bunch of unique and weird stuff.
Yes.
I've seen studies mention endemic. A lot of the endemic, so meaning only found there, a lot of research seems to have been done on the endemic communities of mollusks and other invertebrates. I think also plankton, things like foraminifera, there were very unique ecosystems of invertebrate and non-animal life in these bodies of water. As the Paratethys goes through its various shrinking phases, there is also changes in that life. I saw papers that have tracked the transition of the life in that region from marine to brackish to freshwater as the body of water changed over time. There are also a bunch of extinctions and turnovers as those changes happened over time. The Paratethys also was home to dwarf marine mammals. I've seen references to dwarf seals and at least one species of dwarf whale known to have lived in the Paratethys, a species of Cetotherium, which are baleen whales that at least from what I saw mentioned, are estimated to have grown to a whopping 3 meters
Whoa!
or 10 feet. That's a baleen whale smaller than a lot of dolphins.
Yes. Yeah. Like that is way too small to be.
Yeah. So we've got the island effect in the ocean.
Yeah.
You got dwarfing in this shrinking body of water.
That is cool. And it makes perfect sense because a isolated body of water has all the same issues that an isolated piece of land has.
Yeah. Limited resources, limited space, dwindling food supplies.
You're now disconnected from the populations you would have been interbreeding with, so you can now start to deviate. So you're going to have all the island effects inside an enclosed, separated piece of water as you would on a piece of land.
And I have seen a handful of studies looking across the history of the Tethys Sea, using fossils to identify where there were connections and differences.
Yeah.
So one, for example, that I saw was a study on mosasaurs, identifying regional differences between different parts of the Tethys Sea. And there are studies, especially with invertebrates, with marine mollusks and foraminifera, things like that, showing differences arising over time where bodies of water become separated. Where it used to be these two areas were very similar in their fossil ecosystem, and then eventually they start to become very different around the same time that this mountain building event seems to have happened, where these continents came together and closed off these different parts of the continent.
Yep.
Similarly, I have also seen, for example, with the Paratethys, the shrinking of that inland sea is also suspected to have created land area that allowed land animals to move to new places. I've seen it cited as potentially one of the reasons that the earliest members of the giraffe and elephant lineage were able to spread across Eurasia and Africa in this expansive bits of land that were being left behind as this inland sea shrank away.
Yeah. That makes perfect sense.
Also fascinating, and perhaps more unexpected in a discussion about life of the past, the Tethys Sea is commonly studied as an important part of the background for modern-day organism distributions. So like we were just getting at, oftentimes when researchers are trying to identify what were the events surrounding the origination of this group of animals or this group of plants or whatever it is, we will look at what do our fossils and DNA tell us the approximate timing of this change should have been, and what other geologic things were happening at that time. There have been a number of studies looking at evolutionary radiations and diversifications of modern groups and linking them to changes in the shape of the tethys. For example, I saw a study that noted modern coral reef fishes in the Indo-Pacific seem to have gotten started with an expansion in radiation in the tethys.
Okay, yeah.
Based on when those lineages diversified and where they seem to have done it, that seems to have happened coinciding with the changing shape of the tethys. I've also seen the changing shape of the tethys invoked in the evolution of different lineages moving between freshwater and saltwater habitats. As these bodies of water changed, it encouraged the selection of shifting between habitats. This has been invoked in certain crustaceans and also pufferfish. The pufferfish, apparently, here's a little aside, apparently pufferfish have evolved from marine to freshwater habitats multiple times.
Okay.
Way to go, pufferfish. At least some of those times have been potentially linked to changes in the shape of the Tethys Sea, providing freshwater habitats for them to invade.
Yeah.
I shouldn't say invade, for them to go inhabit. Two other really neat examples that came up a bunch while I was reading. There are a couple of groups of crustaceans today, remipedes and thermospinaceans, which are both crustaceans that are commonly found in caves and springs and like flooded, like saltwater flooded caves, places like that. Today, both groups have distributions across the old world that are kind of broken up and disjointed from each other. But those distributions match the former range of the tethys. So what is suspected to have happened in their evolution is that they are part of lineages that used to be spread across those regions, and then as the waters of the Tethys receded from those areas, members of these lineages were left behind in a handful of different places.
Yeah.
And ended up then evolving separately from each other.
Yeah. That's interesting.
So the Tethys left behind these relict distributions. It's like, you are here. We talked about this with crocs, with how today we've got alligators only in North America and Asia and nowhere in between, because they used to be more widespread. In that case, not only was it land connections, but also global climate changes that stopped them from being able to inhabit those intermediate places. This is that same concept, but with the water disappeared. So these animals can only linger in the places where there's still water within that region that they once inhabited.
Yeah. Well, and I think that's a good, useful reminder that, the coastline is not a more or less straight line, that it has inlets and jagged areas so that you can, if the water recedes, it's not going to recede evenly across all of that, because it's not all the same depth across, it's not all the same shape, so you can get these little left behind parts if it moves away.
And in addition to understanding how the Tethys has affected the distribution of living things, there are also studies that examine how changes to the shape of the Tethys Sea affected climate.
Ooh.
This is, you mentioned this earlier when we were talking about, in the Mesozoic, the Tethys formed part of this tropical continuous body of ocean water, which would have affected circulation and would have affected the global climate. During that time, this would have allowed warm water circulation across pretty much the whole globe, which probably went a long way towards keeping the tropics nice and warm.
Yes.
Another place where I saw the Tethys invoked as part of climate shifts is in the Miocene. So during the Miocene, there is an event called the Middle Miocene Climatic Transition. This is a period of global cooling. It's a period where we see growth in the polar ice caps. We've mentioned this before, this trend in the later Cenozoic of things getting colder over time. There have been some studies that suggest that part of why that happened is because of the way the Tethys Sea changed at that time. I saw one study that used experimental models to model patterns of ocean circulation around the world and see how that affects the climate.
Yeah.
And they found that as the Tethys Sea became shallower and eventually closed off, that cut off a source of warm water from that area, which would have changed global ocean circulation in a variety of ways, including allowing the strengthening of the Antarctic Circumpolar Current, which, as we've discussed before, episode 11, we talked about Antarctica, is the current that goes around Antarctica that keeps all of the cold air and water around the South Pole.
Yes.
Which is a big part of what is thought to have allowed Antarctica to become as cold as it is. And by extension, the general pattern of temperatures across the planet.
Which I think is an important note, because so often when we talk about the temperature of the planet, we typically talk about just like, well, how close to the equator or how close to the poles are you? Which is a big aspect, because that's where the sunlight is hitting more and less. But if you were to pause all the water and air on the planet so that it wasn't moving, but heat could still distribute, it would not settle the way it currently is. Like the way currents move, concentrate and dissipate and move heat around differently. So you can get warmer areas because it is being concentrated, and colder areas because it is being drawn away from.
Yes.
So you can get differing conditions because of the way we move the fluids the on our planet and move the heat around.
Yes. It can also affect climate and weather patterns.
Yes.
And indeed, I did see a mention in one of the papers I looked at that suggested that the closing of the Tethys Sea might also have been a key part of developing the modern South Asian monsoon climate.
Oh.
That when those changes happened that closed off the Tethys, it is also what created the conditions that allow for that.
Interesting.
So the Tethys Sea, these shifts, it's not really a surprise to say that studying how bodies of water, parts of the ocean have changed over time, connects to all these other questions about the way the planet functions, life on Earth and the climate on Earth. So the Tethys is studied not only for the questions of how did things look in the past, but how was life able to get around? How did these changes affect distribution of nutrients and temperature and all these different fundamental aspects of how the planet functions?
Well, it has kind of the same vibe that the plate tectonics did of like, this drives the functioning of the surface of our planet.
Mm-hmm.
When you're talking about an ocean, that has so much more than just water and the stuff swimming in it. Like, this affects everything touching and around that ocean and potentially around the globe.
Yeah. And speaking of the stuff in the ocean and the way that it affects things around the globe and why we study it from a modern perspective, there is one other thing that I will mention, because it's a very important note, about Tethys Sea geology.
Mm-hmm.
One of the main reasons why we have such a thorough body of research looking into the geologic history of the Tethys is not only for questions related to ancient life and climate and stuff, but also questions related to oil and gas reserves.
Ah.
Oil deposits that we use as fossil fuels, are rock formations rich in hydrocarbons. That's the stuff we convert to fuel and then use for all of our stuff.
Yes, yes.
These deposits are commonly formed from ancient sea floors that become covered in plankton and microorganisms and all that, so that the sediment itself is made up in large part of the organic remains of foraminifera and diatoms and all those little things.
Yeah, this is that marine snow that just all the particulate of the things living above falling down to the bottom.
That organic material becomes buried within the rock, and then we can squeeze it out of the rock as oil or gas or whatever we're getting. These kinds of deposits are extremely plentiful around the ancient shorelines of the Tethys. The giant oil fields of North Africa, Arabia, and the Middle East exist because of the Tethys Sea.
Yeah.
Those uber famous parts of the world where you can get lots of oil have been a focus of geologic research for a long, long time, for fossil fuel reasons, which means that we've learned a whole lot about the Tethys Sea.
Yeah.
That's why those are there.
Which is a fun to picture that if you were to zoom out and see all those and put everything back where it used to be, you would be able to connect the shoreline, the coastal area, the shallow sea area that created those and into a pattern. Very neat.
So the Tethys Sea in all of its incarnation, there is so much. This is another one of those sort of foundational topics that the Tethys Sea has come up in a lot of our discussions. It'll probably come up more in the future. Now, I saw so many, while I was doing my research, I intentionally tried to look for a bit at, like, what are some famous fossil deposits from the Tethys, famous discoveries around the Tethys, and it's pretty common for things to be found from the ancient Tethys or the shorelines of the Tethys, but not actually mention the Tethys.
Yes.
Just ocean.
Yeah.
This was ocean habitat. These things lived in the ocean, which is a trend that we on the podcast also often follow. I don't know if we said the word Tethys in the Evolution of Whales episode at all.
Yep.
Which is part of why I wanted to mention some of those famous finds, because it connects dots between a lot of things that we otherwise talk about and hear about quite a bit, connected by the land and water masses that existed at those times.
Yes, yes.
So it has been a whole bunch of fun to do this quick breeze by of the history of the Tethys Sea and how we study it and why we study it. And here, when I first chose it for an episode topic, I expected it to be like the Western Interior Seaway. I was like, yeah, this one body of water, we'll talk about that. It's a whole lot more to it than that.
Yeah. It's almost more of like a concept of we're gonna take this honorary title for the water that ends up being encircled by...
Right. You have inherited the title, the mantle of the Tethys Sea.
Exactly. Yeah, it is... I feel like this is a really good foundational concept, for not only does it put into context a lot of things, but also it just is really good at getting across certain concepts of how do we actually study ancient ocean? Like, how do we define an ancient ocean? Well, we have to do it by the rock, because the water's not where it used to be, and we can't. Water doesn't fossilize and it doesn't sediment, So, like, how do we measure that? How do we name them?
Yeah.
And a lot of those things that I know I didn't consider and think of, and I don't think I don't see discussed very often. So it's a nice extra layer of things to consider and remember.
Yeah. So thank you to Jackie and Aaron for suggesting this episode topic, giving us another excuse to delve into geologic history and the shape of the Earth.
Yeah.
As always, if there are subjects that we touched upon in this episode that you'd like to hear more about, reach out to us and suggest an episode topic yourself. There's a topic request button on our website now
You can
that
use the
you
form.
may have heard about. Nice and quick and easy, and it goes right to our email. And we'll also put a link to that form in the episode description, so let us know what you want to hear.
Yeah.
But before we wrap up our discussion for this episode, we have one last thing to do, and that's our patron question. One of the rewards that our patrons can receive by subscribing on our Patreon is the ability to submit questions for us to answer here on the podcast. Now, this is our first episode of August, which means that it is not officially Snake Month anymore. But we had a snake-related question. So you talked about crocodilians in the news. We'll do snakes in the patron question and wrap up our summer with it.
Balanced as all things should be. This question is from Ryan, who says, I learned on your show that snakes are lizards. So they are, in a sense, legless lizards. What's the difference between snakes and other legless lizards, and where do they diverge? Do we have non-snake legless lizards in the fossil record? If so, how do we tell that they're not snakes?
That is an excellent question.
Mm-hmm.
We've talked about this before. Snakes are squamates. The squamates is the group of reptiles that are lizards and snakes. Snakes are descended from what we would call lizards.
Mm-hmm.
They are a group of lizards that lost their legs and turned into a snake shape. They are far from the only group of lizards that have done this. It is estimated that lizards have evolved a snake-like body with very little or no limbs at least 24 times.
Mm-hmm. Mm-hmm.
This is something that happens a bunch. Today, legless lizards include, but are not limited to, anguines, like glass snakes and slowworms, pygopod geckos, a bunch of different groups of skinks, almost all of the amphisbaenians. There's at least one group of chordilids, the armadillo lizards, that are nearly limbless. This is a thing that has happened a whole bunch of times. Snakes diverge from the rest of lizards probably in the late Triassic to early Jurassic, so they are a very early branch off of the diversity of lizards. But we can also estimate when groups of legless lizards evolved, and I've seen estimates for certain groups as far back as the Cretaceous period. This is a thing lizards have been doing for a long time. And we do have fossils of legless lizards that aren't snakes.
Yes.
I've seen references to fossil pygopods. Those are the legless geckos. I know there are fossil amphisbaenians, which is another group of legless lizards. At the Gray Fossil Site, we have fossils of glass lizards, anguines.
Aren't those osteoderms?
And we know those from osteoderms. Which brings us to the other part of the question. When we find a fossil of a legless lizard, how do we know it's not a snake?
Mm-hmm.
And the sort of broad answer is the same way that we do when we identify them in modern day.
Mm-hmm.
Each lineage of lizards has its own set of features that are distinct to that group. So I've mentioned before that when we study fossil snakes, we are very often looking at vertebrae. The vertebra of a snake will look different from the vertebra of any other lizards.
Yes.
Like a gecko vertebra versus a glass lizard vertebra versus a snake vertebra are going to look different. The skulls are even better.
Yep.
Skulls are going to look different just because they are different lineages of life with different habits and different ancestries that have developed distinctive features. Very much the same way that if you look at a glass lizard and a snake today, if you know what to look for, even though they superficially look a lot like the same thing, you'll notice that one of them is missing those external ear holes, and one of them, the tail starts in a slightly unusual position. Glass lizards have osteoderms, armored bones in the skin, which snakes do not have. They've got distinct features.
Well, and it's and this is adjacent to the question, but it's a very similar situation that people come across of, if snakes are just legless lizards, why do we not call legless lizards snakes? It's because evolutionarily they are different lineages.
Mm-hmm.
They did not come from the same ancestor, unless you go all the way back to the ancestor of lizards.
Right.
Yeah,
But they're not descended from long limbless lizards.
exactly. They are descended from different groups and got to leglessness on their own. It's kind of like if we got a new group of flying mammals, they wouldn't be bats.
Right.
Even if they did the same thing, even if mice started developing membranes between their digits and started growing bat wings, they wouldn't be bats. They'd be flying rodents.
And they would have distinct anatomical features.
Yes.
That are rodent features.
Yeah.
They'd have those ever-growing incisors and those other cool features. Now, the question of how do we distinguish the earliest snakes from their close relatives that were snake-like but not technically snakes, that's where it gets a bit trickier, and that's where we eventually just draw a line. There are snakes in the fossil record, as we've discussed, that have legs.
Mm-hmm.
We don't draw the line at legs. We draw the line at a handful of specific snake-like features. But yeah, if we go back far enough, eventually we as scientists have to just go, all right, here's where we are deciding to say this lineage became snakes.
Yes.
The other legless lizards are, I don't want to say it's super easy, because identifying fossil stuff, especially from just bits and pieces, can often be quite difficult. But if you've got a good fossil material and you know what to look for, you can distinguish different lineages of legless lizards, including true snakes.
Yeah.
Great question, Ryan. Thank you for asking that, giving us a chance to talk some more about snakes, even in this, the aftermath of True Snake Month. Thank you to all of our patrons who support us, who helped to make Snake and Croc Month successful this year, who submit questions for us to answer. Thank you to all of our listeners who listen and who request topics for us to talk about and keep the podcast going.
Mm-hmm.
If you'd like to learn more about this topic, check out the blog post. There is a link in the episode description. There'll be a bunch of pictures of maps of the continents over time to show some of these changes we've been talking about, links to more information. Also on the website, there's a request topic button, link in the episode description. That's new and exciting. Another reminder that we will be at DragonCon at the start of September, so if you're going to be there, come say hi.
We might be less recognizable than we usually would be.
One of us for sure. It's going to look real weird.
It's going to be so weird.
It's going to be awesome. As always, feel free to join us on the social medias, join our Discord, join us and support us on Patreon if you are able and willing. Find links to all these fun things in the episode description. We release episodes every fortnight.
Mm-hmm.
Who knows, maybe the next one will also be something to do with the ocean.
I mean, you know,
We seem to be on a bit of a trend.
we're cast adrift at sea.
We're trying to find it. We're trying to find that land again.
I just got a picture of this as a sequence as we're like on a raft. It's like, well, while we're out here, might as well talk about.
Might as well. Listen, our volleyball friend left us, and now we got nothing else to do. I've got nothing more to say. Sign off phrase.
Goodbye.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.